Hi there, it's Jason Gorman from Codemanship here with the first in a series of videos on test-driven development for C Sharp. Now, if you're not familiar with TDD, in this first video, we're going to be introducing you to the absolute basics of test-driven development. And I'm going to be using NUnit to write my unit tests with. If you're not familiar with NUnit, I'll be posting a link in the description below. Now, you may have heard of test-driven development. You may even have tried it. Test-driven development simply means using tests to specify what we want our solution to do. Tests as specifications. So we write a test that fails, and that describes something that the software currently doesn't do that we would like it to do. And then we write the simplest code to pass that test. And then if necessary, we stop and we look at the code that we've written, and if it needs to be made simpler or if it needs to be made easier to understand, or if there's anything that we think will make the code harder to change going forward, then we refactor. So test-driven development works in these micro cycles where we write a failing test that describes something we want the software to do that it currently doesn't. And then we write the simplest code to get that test passing, get it passing quickly. And then, if necessary, we refactor the code to make it easy to change going forward. Okay, and then we work one test case, one example at a time, fleshing out a solution design based on the simplest thing that each test requires. So our solution will get more general as we add more and more test cases. Now, as I said, I'm using NUnit, and the example we're going to be doing here is a very simple one. It's just a shopping basket that contains a list of items that have a quantity and a unit price. And our requirement is we need to be able to total the items in the shopping basket. Very, very straightforward. And we would typically start, if we're doing test-driven development, with the simplest example of a shopping basket we can think of, which would probably be an empty basket. What is the total of an empty basket? Well, we'd expect it to be 0, obviously. So I'm going to write a test method in this test fixture here. In NUnit, a test method is just a method, a plain public method that is tagged with the attribute test. It needs to be public void, it can't return anything. And then I'm going to name this test method to describe what the test is. So this is the total of an empty basket. Okay. Accepts no parameters. We can have tests that accept parameters. We'll see that in a later video. But for now, a basic test method in NUnit is just a public method that's void and that accepts no parameters. The name of the test method describes what the test is. So people reading this can see very easily, this is the one for the empty basket. Okay, now, what confuses a lot of developers about test-driven development is how can we write the test first for something, for a class or a method or a function that doesn't exist yet? Surely we need to declare our basket before we can write a test for it. But the clue is in the name, test-driven development. Our design is being driven by what the test requires. So we actually start by using, for example, a basket in the test. Let's do one there. And there is no such thing in, there is no such thing in our project at the moment. So by doing that, essentially, we're saying, well, okay, we're going to need one of those. And at the moment, it thinks it's a property, so let's keep typing. Okay, hopefully it's got the hang of that now. So we want to create this type basket. So this is the golden rule of test-driven development. We don't declare any solution code unless we have a test that requires it. So we use it in the test first, and that tells us, oh, we're going to need a basket class. There you go. So we have our basket class. Let's create an instance of that. And what we're going to do is we're going to pre-populate it with a list of items. Again, there's no such thing as an item. So let's create that now, create that type item. And let's just begin with, it can just be an empty list. There's nothing in there, basically. And hopefully that all works. Yep. So we've got our basket, and what we want to do is we want to assert that the total for that empty basket is 0. So again, I'm imagining we have this total property, but we don't. So that gives me permission. Let's create a get only property. There we go. We need to import something. Let's import our, we need to create a constructor, sorry, for basket. There we go. That should all work. So we're working backwards from the test to the solution code. Okay. And at the moment we're throwing a not implemented exception. So if I were to run this test, it would fail. We'll talk in a later video about running tests and seeing them fail. But for now, what we've got here is a test that fails. Let's just run that just to confirm. And with a bit of luck, there we go. We'll get a red bar or a red light, as we say. It says, okay, our test is failing. It's failing at the moment because of this not implemented exception. We will talk in a future video about why that's maybe not the reason we should see it fail. But for now, that is fine. So we now have a failing test that describes what the total for an empty basket should be. So then we do the simplest thing possible to make that pass. So let's get rid of that exception there. We don't need that. And what we could probably do here is just have a very simple, just return 0. And that should hopefully pass our test. So that is the simplest, quickest thing I can think of that will make our tests pass. So we wrote a failing test. We did the simplest thing possible to pass the test. Now, this is another place where a lot of developers who are new to TDD get a little confused. Obviously, not every basket total is going to be 0, but that is the simplest thing we can do to pass the test. It's not a general solution for totaling the items in a shopping basket, but it is the simplest thing we can do. It gets us passing our tests quickly, and the advantage of that is that now we've got something that kind of works for that particular test, and we can sit back because our tests are passing, we can relax and think about the design. Now, refactoring, there's one thing here that's bugging me. I don't think that these are classes, item and basket, really belong in the same file, the same source file as the test. So I'm going to move these. If I can remember what the shortcut for that is. Let's just look it up. Control RO, okay. RO. Let's move it to its own file there. And as soon as I've moved that, I should rerun my tests. So these things work hand in hand. Because we're writing tests to check that our code is working, or rather to say what it looks like when the code is working, one of the nice side benefits of using tests, unit tests as specifications, is when we're finished, when we've got it working, we're in a position to use or reuse those tests to make sure that when we change our code, for example, when we're refactoring, that we haven't broken anything. So let's move this one as well. Let's move basket to its own file. Okay. And again, I immediately rerun the tests. And we should probably think about moving these to a different namespace there. They probably should be in a namespace called .test. They are actually solution code. There we go. Immediately rerun my test. So you'll see in these demonstrations as we go through these videos that I run my tests very, very frequently because I'm super paranoid about whether or not the change I've just made has broken anything. And again, we'll just put this in its own, in a more suitable namespace, not in the test namespace. It may be conventions in .NET. Some teams do it that way, some teams don't, to actually put them in a separate project. And that's absolutely fine. I often do that as well. But for this demonstration, we're going to kind of leave them where they are for now. It's good that they're in separate files and they're in separate namespaces. That's absolutely fine. Okay, right, so back to our test. So we've got this test passing. I'm happy about that. But obviously, if the basket's not empty, then the total's not going to be 0. So we need to keep going. I can think of more examples, more tests that our solution will currently fail. So let's write a second test here for a basket that's got one item in it. So let's imagine of a single item in our basket. Okay, and now we have our basket class. So it starts to fill in some of the details for us. And this time it's not going to be an empty list. It's going to be, well, let's pass in a new item. But this time we need to know about our items. We need to know something about our items. We need to know how many there are. So what's the quantity and how much each unit costs. Let's imagine it costs £100. And now we can create that constructor. Let's give these meaningful names. That's the quantity. And that's the unit price. Okay. Back to our test. And we want to check that the total of this basket is 1 times 100. So it should be exactly 100 and our basket total. Okay. So one of the things that I like about modern editors is that as we flesh out more of our solution, the IDE will start filling in the gaps for us automatically. So there's a lot less typing involved. Okay, now let's run our tests. And this one will be failing because, okay, let's take a look in our item. Let's quickly get rid of that. I'm going to run the test again. So let's just see why it's failing. It should be failing because we're returning a hard-coded total of 0. There we go. Right. Now, to make this pass, well, we don't need to know the quantity at the moment. So let's just create a read-only property for price. And let's go into our basket. And this time, well, we can do a branch here. So if, let's assign this to a field because we're going to need to look at those now. We don't need to expose it like that. And now we can say, okay, if our items collection is not empty, then let's make it equal to the first item's price. Otherwise, just return 0. So that's the first solution that popped into my head. It was the simplest thing I could think of. Okay, both our tests are passing. That means it might be time to think about refactoring. I'm reasonably happy with my basket class and with my item class. They're about as simple as we can make them at the moment. Let's take a look at our test code. Again, yeah, it's readable. It's easy to understand. So I'm happy at this point to move on with our third example. Let's imagine now there are 2 items, each with a quantity of 1. So again, there's our basket. And this time in our list, we need 2 items. So a quantity of 1 at a price of 100. And in our second item, we have a quantity, let's say a quantity of, oh no, both quantity of 1 and a price of 200. So we're expecting the final total to be 100 plus 200 or 300. Okay. Not equal. So we're gradually fleshing out this design, fleshing out the logic of totaling one example at a time. We're taking little steps, and with each step, we're making a small number of design decisions, and then we're getting feedback. We run the test, we see it pass, and then we can sit back and look at the code that we've written, look at the design decisions we've made, which will just be a handful of decisions, and then we can bring a lot of focus to each decision so that if we're not happy, we can refactor before we move forward. So we tend to find that code that is test-driven is a lot more maintainable. It's a lot easier to understand. It's a lot simpler because we're bringing a lot more focus to each design decision we're making. The batch sizes of these code reviews, little code reviews, are doing are much smaller. If you're used, for example, to doing pull requests and doing code reviews at that point, you might have made dozens of design decisions or even hundreds of design decisions, and then someone has to review all of those. Well, it's not going to happen, is it? So we've got our basket. What's the total? There we are. And this is going to fail because it's only looking at the first item. So it's going to be 100. And there we go. Yep, expecting 300. So we need to do something a bit more sophisticated in our basket. Well, how about instead of doing this, we could aggregate. So let's aggregate basically with an initial value of 0. And we've got a sum and our item. So we have a little lambda expression here that adds the item price, and that should be, it's going to say it's an int, isn't it? I'm going to have to give these a type. So let's make the sum a double and the item an item. There we go. Nicely, strongly typed C#. Okay. And now when I run this, it should be basically totaling all of the items, even in an empty basket, come out with a default of 0. The total, there we go. So we got something a bit more general now. So we're leading towards a general algorithm. There's one more test case, I think, here, which is what happens if one of the items has more than one, a quantity of more than one. So let's take this final step. Void total of quantity 2. So when there are two units of a particular item. There's our basket. We only need one item to do this. The simplest data set I can think of would be, okay, with a quantity of 2 and a unit price of 100. So we're expecting the total of this to come out as 200. Okay. But when we run this, it's actually going to come out as 100 because it's not actually using the quantity as yet. Okay, lovely. So one last step to make this work, we need to multiply the quantity by the price. Oops. Notice again here that I'm still working backwards. Okay. Oops, no, that was not what I meant to do. There we go. And then if we go into our item there, simplest thing we can do really here is just expose it using a getter. There we go. Back to our basket. That's looking okay. So we can rerun our tests. Okay, all our tests are passing. All our logic is here now for an item, for a basket holding an arbitrary number of items, including no items. It will total basically based on the quantity and the price. It will multiply the quantity times the price. So I can't think of any more failing test cases for this. So it's time to think here about refactoring. And there is one thing that's bugging me here, and that's this little bit of code here. This is an example of what we call feature envy. This property of basket has envy for the features for the fields of items. So arguably what we're saying here is that basket knows too much about item. or item is exposing too much information to basket. And the problem with feature envy is that when one object knows too much about another object, chances are when we try to change the object that it knows about, we're going to end up having to change basket as well. So if we want our items to work differently, then we need to try and hide, to encapsulate that data so that basket doesn't need to know about it. And a very easy way to do that would be to extract a method here. Let's call it subtotal. A subtotal method, you'll see there. And I don't want it to be static, I want it to be an instance method. You'll see why in a minute. And it's going to pass the item into that method. So this will become a helper method on basket for now. Let's just do that. Okay. And as soon as I've done that, immediately rerun my tests. Now this method here, subtotal, it's all about item. It's all about the item. It's not about the basket at all. So arguably we should move this to where it belongs, which is to item. So I'm going to move this instance method to the item parameter there, to the item object. It's going to extend the visibility of this private method so that basket can see it. That's absolutely fine. It's kind of fixing it for us there. Lovely. So now we have this subtitle thing, which we discovered through the process of refactoring. And that's how a lot of design decisions get made in TDD. We don't necessarily make the decision up front that, oh, we're going to need a subtotal method. We look at the code we've written, we say, oh, we've got feature envy there in basket for item about the quantity times the price. What should we call that? We extract a method, we move the method, and therefore we've discovered that abstraction there. We've discovered this subtotal method through the process of cleaning up our code. Now that we've got this, take a look at these helper methods here. It's already telling me this, that we don't really need them. So we can probably try inlining this. I'm just going to look up what the, or maybe we can't inline them. Maybe we can, no, it doesn't want to do it there. Can I inline that? No, it doesn't want me to do that. What I would wish to do is to get rid of these methods here, but unfortunately because I've made them these auto properties, it's not that easy to do that. So we're going to live with them for now, but we can make them private quite easily. Let's just take a look and see what the Roslyn code is. Yeah, we can make quantity private. So we're hiding it from basket, and we can make price private. So those properties now are encapsulated inside item. Basket doesn't need to know about them. Basket just needs to know about the subtotal. Okay, lovely. So that's our shopping basket. We've written 4 tests. We've discovered a very simple design with a basket and an item and a couple of useful methods. And we've not planned those up front. We've discovered them through the process of writing failing tests that describe what we need our software to do, and through refactoring our code, in which we've discovered that, oh, there are other methods and other interesting features in here as well that would make the code easier to change going forward. So that's test-driven development. It's a microcycle, a micro-iterative process where we specify our software by writing tests that fail. We make the test pass as simply as possible and as quickly as possible. And then, if necessary, afterwards, we refactor our code to make it easy to change going forward, easier to understand. Look out for complexity, look out for duplication, look out for coupling, like feature envy, for example. And if necessary, you eliminate those problems by refactoring before you move on to the next case. And as we add each new example, each new test case, we generalize our design. So we come up with the simplest general design that will pass all of our tests. This is a process that Kent Beck, in his excellent book, Test-Driven Development by Example, calls triangulating. We're triangulating a design using one example at a time, generalizing as we go. So with each new test case that we add, as our tests get more specific, if you like, our solution gets more general. So that's our first video. I hope that's given you a flavor of what TDD is all about. Those are the basics, but as we'll see in later videos, there's more to it than that. If you do this, if you practice this, it will get you a long way. But as we will see in future videos, there are other practices and other ideas that can be very, very helpful when you're doing test-driven development. And we will look at those soon. So I will see you in the next video.